Hello everybody. I am going to talk to you today about our new unit and our last unit for Chemistry B. We actually have 3 units left of the year, but we're only going to get to one of them, a very brief overview of the second one, and we're completely eliminating the third one. So it just is what it is. It's not going to be a huge deal. The one that we're leaving out is periodic trends. We don't usually get to that one very much anyways in June, so it's okay that we're just going to skip it. So our last unit is going to be on atomic structure and electrons and how electrons emit light. So a lot of it may be something that you've been familiar with in other science classes before, so you may recognize a lot of the things that I'm going to be doing, but we're going to add to it and specifically concentrate on how an electron emits light. So the first thing you're going to need to do is take your calculator and put it away. We don't need to do any more calculations this year. Yay! But what you do need is a periodic table. So hopefully you still have one. If not, I am going to attach one to the lessons. You can find one on the internet, anywhere. This is the pink one that we've been using, that we use all the time. So I'm going to draw on this one. I'll also post a picture of the one I drew on so that you can see sort of what I'm doing for here. So you can take notes during this video if you'd like, or I will attach a summary of the things that you should know. So this periodic table we've been looking at all year. This tells us a lot of information, but the information that we are going to be using for atomic structure really comes from everything that you see here. So we've been looking at atomic mass before, but what all these atomic masses mean and why they're in a decimal place and not a whole number is what we're going to learn about this year, the rest of the year, sorry. These numbers here as well. So these are the period numbers, and we've known them as period numbers. But the periodic table is actually a map. It's a map of how atoms are arranged. And the period number is also what we call an energy level. An energy level is also what is called a quantum number, if you want to be really sciencey. So the period number is equal to the energy level as well as the quantum number for each of these. And as you go across, so energy level 1, quantum number 1, see that it only has 2 elements, hydrogen and helium. That's because the first energy level only holds 2 electrons. So you may have remembered this from drawing something called a Bohr model in early physical science classes. The second energy level contains the first 2, lithium and beryllium, and then it has these 6 over here, so boron all the way to neon. So that's energy level 2, and notice how there's still 2 in the first sort of section, and then there is 6 over here, so a total of 8. So 8 electrons can fit in the second energy level. Then you move on to the third energy level, and you see the same thing. So there's 2 and then 6. So energy level 3 can hold 8 electrons. Then you go down to energy level 4. So quantum number 4, energy level 4, has the first 2 again here. Then you add in the transition elements. So there's 10 here, and then the 6 from over here again. So there's 18 electrons that can fit all the way across here. So it goes 2, and then 8, and then 18. Remember those numbers? I bet you do. And then if you come all the way down here to energy level 6 and 7, remember that that's where these the rare earth elements came out of, and they actually go right here. So there are 32 elements that can go all the way across here, electrons. So we'll learn more about the energy levels and how the energy levels fill in the next lesson. But today I want to concentrate on the information that the periodic table tells you. So take a look at the element tile. This is an example. So it's giving you an example of hydrogen. So the name, we all know the name. We know the symbol. That's fine. Atomic number. Now, atomic number is something that you've used perhaps, but the atomic number also tells you a couple of different things. The atomic number also tells you how many protons an element has. It also tells you how many electrons an atom has if the atom is neutral. So protons don't change. Whatever the proton number is what the atomic number is. That doesn't change. But electrons, we know atoms can gain and lose electrons. So electrons in a neutral atom will be the same as the atomic number. But if the element is an ion, like meaning it's lost or gained electrons, the electron number is not going to match the atomic number. However, it will always match the proton number. So atomic number and proton number are always the same. It will be the same as the electron number if it's a neutral atom, not an ion. Okay, so that's what atomic number tells you. What about atomic mass? What does atomic mass tell you? So all of the atomic masses on the periodic table are all in a decimal form. So it's not a whole number. That's because the atomic mass is an average. An average atomic mass is what the atomic mass of the most abundant form of that element is. So each element has, every element has something called isotopes. Isotopes are forms of the same element. Let's take carbon, for example. Carbon-12 is the most common form of carbon on Earth. But carbon has several different isotopes. Carbon has a carbon-13 isotope, carbon-14, carbon-15. Those are all different forms of carbon. It's still carbon because the atomic number is 6 and the proton number is 6. However, the neutrons are the only thing that changes. So to make an isotope, the number of neutrons in the neutral atom will change. So the atomic mass is the sum of all of the protons plus all of the neutrons in the element. The reason why it's an average is because all of those isotopes that exist are averaged in together. The whole number atomic mass is the most used form. So the nearest whole number, so carbon is basically carbon-12 with some change. The most common form of that element will be the average. There is something called calculating the percent abundance for isotopes that we would normally do in school. We're not going to do it. So if you want to learn about calculating the average abundance of isotopes, you're welcome to do that. Let me know how it goes. So the isotopes are different forms of the same element, same element name, same element symbol, same number of protons, same number of electrons, not the same number of neutrons. So the only thing that changes in an isotope is a different number of neutrons. So that's what the average atomic mass means. Now there is something else called a mass number. Mass number, almost exactly the same as average atomic mass. However, the mass number is the specific number for that particular isotope. So if you're talking about carbon-12, the proton number is 6. That means the neutron number is 6. So the mass number is 12. If you were talking about carbon-13, it would be the proton number is 6. The mass number would be 13 and the neutron number would be 7. So you would have to subtract the number of protons from the mass number to figure out how many neutrons that you would get. Okay, so let's label the periodic table with some of that information. So I'm going to swivel down.